All right, let's go ahead and get started again. It's my pleasure to introduce our next speaker, who is kind of famous because I've heard this term EMBER thrown around a few times today, which you may know is written by a couple of authors, Anderson et al. So I'm very pleased to introduce et al. Hiram informs me that Phil Roth is actually the chief architect behind the EMBER dataset and model. Phil is a data scientist at Endgame, where he has led the development of Malware Score, bringing it from a small proof of concept that lost a Kaggle competition all the way to a deployed product that is automatically trained and updated. Previously, he developed image processing algorithms for a small defense contractor. And a fun fact about Phil is that if you ask him for a fun fact about himself, he will respond, "There is nothing fun about me." But then if you press him on it, he will tell you that while earning a PhD in physics, he used a machine learning algorithm and the ice cube detector at the South Pole to search for neutrinos from other galaxies. So let's give it up for Phil.
Is that working? Is that, no? Yes? Do I need that? Yeah. All right. Thank you. Thanks. All right, yeah, so I'm Phil Roth. I'm a data scientist at Elastic now, and that is my first slide. So yeah, 2 weeks ago, Endgame was acquired by Elastic, so this has changed here, but luckily, the acronym doesn't need to change. This very important acronym that I came up with in the shower one day. And so just shout out to Nate Fick. Thank you to all of our executives for prioritizing maintaining this acronym through the acquisition. And then 20 minutes ago, I got this Slack message from Rich reminding me of when we were discussing this months ago that this is a better acronym. So we're going back. Yeah, this is it now. This is from here on forward. All right, yes, another note. I'm going to give some demos and stuff. The code for all that stuff is already up there. Go ahead and check it out and follow along. Yeah. So what are we going to talk about? What's new in EMBER? We updated the EMBER dataset a couple months ago. Some talks have already been using the newer set of features and set of samples. I'll talk about what's changed and hopefully go into a little bit about what motivated those changes. And then the new information kind of enabled some different analyses, and so I'm going to do just stick my toe in the water and do a little bit of that. So that's the next two sections, and then we'll just look a little bit back. So what is EMBER? It's a collection of features from 1.1 million PE files that were scanned sometime in 2017. This was the original release. That was in spring of 2018 that I released this. Yeah, it includes a benchmark model and code to calculate all these features on new samples that you might have. So just a couple months ago, we did the same thing. Released now from samples that were scanned sometime in 2018, but it's similarly, there's benign, there's malicious, there's unlabeled. We kind of lowered the number of unlabeled samples because those were not used as much, and we added new features which kind of made the whole thing bigger, so we wanted to kind of shrink it back down a little bit to keep the data download the same size. Yeah, so in both of these releases, there's benign samples that were originally seen prior to 2017 or prior to 2018. So all of those pre-2018 samples that are in this new release were already seen in the previous EMBER release. So not only are there new samples, there are also kind of not only new samples and new features, there's also new metadata. One of the main requests we got when we got emails about the EMBER dataset was include the MD5, and so we went ahead and did that. We also, for malicious samples now, we're including the AVClass. And so this is an open source project. You can go check it out. And there's a paper that goes along with it. But what the AVClass authors were looking to do was kind of take the labels that all of the vendors kind of assign to malicious things. The families, they all have different conventions. They all have their dots and dashes in the different places. So AVClass tries to distill all that down to just one name. And so we ran it on all the malicious samples that we included in the data set, and we included the output here. Yeah, so EMBER 2018 is also a harder data set, and so we have to go back to the 2017 release. We released a model that had just default light GBM parameters, and it already performed really well. Like the data, the model performed on the test set really well because we didn't include samples that were kind of hard to classify. It was too easy of a data set. So this time around, we tried to fix that a little bit. We wanted to make it a little harder. So we prioritized the inclusion of .NET samples, packed software, 32 and 64-bit samples. And big thanks to Hiram, who kind of headed up this. He kind of handled the sample selection this year. So there's a couple other decisions that went into it. We relied on the trusted tag in VirusTotal to, that's what we keyed on for benign samples. And then we allowed some vendors to have called it malicious. Just a few, still a small number. Presumably, when they're doing that, that means there's some disagreement about the sample. That means it's harder to classify. And so it was good that we included it in there so that any models then built on it, they're going to have a more difficult time classifying. So that's on the benign side. On the malicious side, we did not include. We didn't use like a bright line threshold, like above this threshold, everything's malicious. It's a little more fuzzy. And then we also prioritized samples that were included in malware reports from 2018. And grab these slides, get the links. These are the links to all the reports that we used. And one more thanks to Hiram for this. Another point on sample selection for what was to be included, and another thanks to Sven, who did all this work. We did a density analysis in the feature space and kind of trained a cover tree, which is kind of like a clustering, which allows you to do nearest neighbor type searches. So he built all that and used that to find samples that were just way out there in feature space. And so we did not include those. And we also eliminated samples that had the exact same feature vector or even something similar. So yes, if you download the 2018 data and find it much cleaner and nicer, you have Sven to thank. All right, so that's kind of the sample selection. The new features, we added features derived from data directories. It's a new handling of ordinal imports, and also we incremented the leaf dependency to the newest version. And I think that last thing alone means we kind of broke backwards compatibility on the features. I don't think there's any guarantee that our feature calculation is going to be the same if you use Leaf 0.8.3 versus 0.9.0. So that kind of empowered us to go back and make more changes. Because it breaks backwards compatibility, we went back to the original EMBER release, EMBER 2017, and recalculated the features. And so we're releasing these new version 2 features for the old EMBER samples as well as the new EMBER samples. So this is kind of the line in the code that was updated for the ordinal imports. You can see so this is actually the first sample, I think, in EMBER 2018. And so that was also in EMBER 2017. So you can see what it looked like, what this one imported library looked like. The last function is an ordinal import, and before that was just empty. Now we're assigning an ordinal name with a number where it is. So this should help. Sven told me the data was way out of whack earlier, and there would be a lot of ordinal imports on some samples, and then the empty name would get hashed to the same place, and then that feature would be just way out of whack with all the others. So this probably helps after the hashing create like a more even data set. So this is a quote from our original paper. The feature set we release in EMBER contains all the information required to recreate features for the Adobe Malware Classifier, and it turns out that was just an absolute lie. Sorry about that. So we wanted to go back and fix that. So that's kind of why we included the data directories. Sorry, this is a screenshot of code, but it kind of describes it here. It's like we're just taking all the data directories and then including the size and virtual address and then hashing that into the feature vector. And then I'll talk a lot more about the Adobe Classifier in the next section, but that enables us to do some comparisons. Along with this new samples, new features, we have a new model. It is no longer just trained with default light GBM parameters. We did a small grid search. This is the grid that we searched over, and then these are the best fit parameters we found, and these are the parameters then, yes, that we trained the EMBER 2018 benchmark model on. This is the performance of that model. Compared to the EMBER 2017 model, you can see that the area under the curve is not as good. That kind of reflects the kind of harder data set that we chose, and especially the detection there. You can see that that's suffering. Unfortunately, the new model is not completely reproducible. So I went back and I used those same parameters, and I just trained 10 models right in a row, outputted them. You can see they all have different hashes. They're all different a little bit. If you diff the files, not only are some of the junk at the end that GBM includes different, but also some of the trees themselves are different. But they're really close. So this plot shows the benchmark model, the rock curve in black, and then those 10 models in red plotted on top of it. So you can't even see the black. They're really close. In the whole test set, the maximum difference between the benchmark prediction and one of these 10 random models prediction was 0.007. So it's important to keep in mind, but if you went and trained your own, I don't think it would be that much different from the benchmark model. But the benchmark model is distributed with our download, so use that one. This is the GitHub issue in LightGBM, which kind of tells me why it can't be reproducible. I didn't dig into the code or anything, but it's it's the bagging we're doing, and we're using multi-threading when training the benchmark model. So we thought those were important enough to sacrifice this reproducibility. All right, so that's all the changes that I wanted to talk about. The downloads are up there. This is in the main README of the repo. Please go get this data. Lots of you already have. That's great. Tell us what you think. All right, so there's new features. And those, like I said, those new features kind of enable a comparison to this old Adobe Classifier. This is a classifier that was released by Karthik in 2012. The code and the paper are all available. I just want to, focus on how early that was. Maybe people in this room were doing machine learning to classify malware before that. Probably some people, maybe not publicly. But this was really early to the field before I was even in security. So big props to Karthik there. And I have to give him that credit because I'm going to criticize his classifier for the rest of the talk. Sorry. These are the 7 features in the Adobe Classifier. Karthik's paper talked about having 100 features or so, and he was able to reproduce the kind of accuracy of a model based on 100 features with just these 7, or get pretty close. And now it's possible to, with his code and with only the EMBER data release, to get the Adobe malware classifier scores on all these samples without going back to the original data. But there are caveats. The 2 Python PE file parsing packages, Karthik used PE file, we're using Leaf, and they can disagree. First of all, they can disagree about the order of the sections. So the virtual size of the second section is going to be different. And this is true for maybe 200 or so samples in the EMBER 2018 dataset. And you can see an example here. And then there's one other thing. They can differ about the number of sections that are in a file. And this is one example of that. There's a lot less of these. I think it's when the files are very small. You can see this file is 300 bytes, but it still qualifies as a PE file. We probably shouldn't have included some of these small files, but that's maybe we should have done more filtering. But when it is this small, these 2 packages can disagree. So if we get all those Adobe Classifier scores, so Karthik said, all right, his classifier has 4 decision trees by these 4 algorithms here. And he asserted that if any of them trigger, then the thing's malicious. So I just took the output of those trees as 0 and 1 and then averaged them so that you can get a score of 0.25, 0.5, 0.75, or 0 and 1. And if you do that, you can plot a rock curve because you can choose different thresholds, and then you can compare that rock curve to the EMBER. And obviously, it doesn't compare very well. The performance is not as good. But you would say, no, that's unfair. The Adobe Classifier was trained on 2012 data. Of course, it's going to go out of date. And I would say, yes, you're right. So you can go back and train a light GBM classifier on just those 7 features. And with default parameters or something, and you can do it on the EMBER 2018 training set and then compare the performance on the test set to the EMBER benchmark model. And again, the performance doesn't compare very well. And you can say, well, you can optimize that, and you can, but the performance doesn't compare. And so what I want to say is, including features is great. Features are cheap. Throw them in there, use them. I have seen feature selection, improve model performance, but that's really, when I've seen it, it's more in limited, one-off situations where you can almost, overtrain or overfit. This is the sort of Kaggle competition situation where you can just be working on the same data all the time and be combining features and throwing them out and things like that. The Adobe features and maybe the EMBER features too are kind of like bookkeeping features. They're like, this is just, they're generally describing the layout of the PE file and saying, it has so many of these things and this thing is so big and everything. And that's good for identifying patterns, if malware authors are using the same code base and they're just slowly evolving them. But then those bookkeeping features, those patterns can quickly go out of date. And features that directly indicate maliciousness are better, but they're much harder to find. And you can update your model more often than you can update your features. So I definitely suggest using all those features, and maybe the feature will come in handy later, even if it isn't right away. So, okay, so there's one other new kind of class of data that we're including, and that's the AVClass Labels. And so you can kind of ask different questions. And so I went ahead and kind of answered some of those questions at just a high level. Well, I don't know, if you're following along, maybe you can see the slides and you can see those names. Sorry if they're too small here. But here, this is kind of the top 15 AVClass labels that show up in the training set and how often they show up in the training set. That's on the left. On the right, then, we have the test set performance, that test set detection at a 1% FPR threshold. And you can see in the red line, that's the overall detection rate across the whole test set. And you can see the different families. Some families we do better on, some we don't do as well on. And that's to be expected. I went back, and then any family that we're doing poorly on, more poorly than the overall average of 0.965, I then went back and increased the weight and then retrained and got a new model. And it didn't really change much. Same performance, and that's kind of expected. That's kind of what a gradient boosted decision tree is doing anyway. But I don't know, that's kind of the type of thing, new type of investigation you can do with EMBER 2018. Probably more interesting is going to be oh, there's this feature that I came up with that's outside of EMBER that now allows us to more accurately classify one of the AVClass labels. All right, so I wanted to look back a little bit. This section's a little self-serving, so I'm just going to go through it. But this is really what I wanted to say, which is that when we put EMBER together, we kind of, at least what I expected was it would be like a new machine learning benchmark, and people would come along and improve on it and just keep beating scores. And I haven't really seen that, and I think there's some debate in the machine learning community if that's even useful for things like MNIST. So maybe it's a good thing we haven't seen that, but we have seen it being used as a resource for learning the field. That's a lot of the emails that Hiram and I get. That's great. It's great to see those. It's useful as a common reference point, just if you're doing some kind of other analysis. And it's definitely been useful as a target of adversarial attacks. Yeah, I was going to say, I've seen EMBER used a lot this weekend, so this slide was accurate 36 hours ago, but it might not be anymore. These are some clips from the emails, people asking about it. Please keep doing that. This is just some mentions last year, and this is just to drive home the point that none of them were of oh, we improved the score this much. And yeah, Hiram put together this whole static evasion competition. EMBER was a big part of that. Hiram released 50 malware samples along with 3 different malware static classifiers and asked competitors to iterate on these malware samples, change them without changing their output in a sandbox to evade those classifiers. It was a great competition. It took 3 weeks or so. Is that right? 3 weeks? 2 weeks for someone to get a perfect score? Maybe as a field we'll get better to the point where it takes 4 weeks, I don't know, to bypass everything. But no, it's great. I think people learned a lot. There's a great write-up. Please go look at that. Hiram just wanted me to mention it so that I include this chart, which is EMBER was the most difficult to evade in a very scientific poll. And yes, this is given to me by Hiram, and it will be the only pie chart included in one of my talks ever. So, all right. So that's all I got. Thanks a lot. All right.
Is this one on? Yes. All right, thank you, Phil. We'll take questions now. We've got a few minutes for some questions. If anybody wants to give, yeah.
Hi, Phil. Awesome work. For the AV class output, are you only giving the single class that AV class gives, or are you using the flag to give all the classes that AV class thinks it might be? Is it just a string or a list?
Oh, no, it's a string. Just one. Okay, cool. Just one. Yeah.
Awesome.
Hey, I just wanted to say hats off to you and Hiram for putting this together. These are awesome data sets. Since you mentioned you were putting in more Packers in this year, do you know what the distribution of Packers looks like? Is there just a lot of UPX? Are we talking more exciting ASPack, the MITA?
I think you can use the AVClass labels to answer that question, but yeah, I don't know off the top of my head without going back to the data.
I noticed you were filtering the data that was going into this data set. Is there a reason why you prefer that method over, let's say, giving 2 sets of indices or something like that? One to what you think is the go-to data set, but just give the overall thing. If people are concerned about you changing the distribution.
Yeah, I mean, like the distribution of, the distribution of PE files, I think, in the wild is a tough question that I don't even know the answer to. So yeah, there is the question of like, should we be filtering? I like the idea of including everything and then kind of like including code that filters and then trains a model. That, yeah, I'll write that down. But yeah, I have bad answers as to like what, should you include everything you just see, like everything you ingest in a model training or something, or how do you model like what you're going to see in the wild? And should EMBER do that? I don't even know.
So they were not actually filtered; they were preferred in a sample, right? So we shifted the distribution, but we did not truncate the distribution.
But the
data set itself put in more .NET files. Yeah, by sampling, by per sampling. From something original. That's right. So we can't. Yeah, I'm just saying.
Yeah, I mean we can't include everything, and so there's gonna be a decision as to what we include, and yeah, so this year it was more, we want to make this more difficult, and then we also want to filter out outliers and duplicates.
Yeah, the duplicate parts is
Okay. So I hope this is a bit of a softball, but so you mentioned that one of the goals that you guys had in mind when you were first creating this data set was that it would be like a benchmark that people would be.
That might have just been in my mind. I don't know if it was in others.
I mean, it's an admirable goal, right? I guess one of the things that's kind of, at least in my thinking, kind of preventing that, right, is pretty much if you want to iterate on this model, right, you pretty much have to have a virus total license or some other huge data store of these binaries somewhere. Do you have any thoughts about how to maybe move towards something that's more, I don't know, democratic in terms of like being able to iterate on models like this and actually make a true benchmark?
No, I mean, this is the best idea we have. Like, and a lot of this data isn't ours to release. Like, and that's why it's kind of like a derivative thing that we're releasing. Yeah, no, I don't know how we could make this bigger without kind of like stepping on license agreements that we already have in place. So, but yes, yeah, there are things we could do, but I don't see us being able to do them from like a legal or licensee perspective.
Can you comment about the labels? How are those derived?
Say that again?
The malicious benign labels.
Oh, the labels.
How are you deriving it?
Yeah, last year, EMBER 2017 set, it was more of like a, no vendors said this was malicious, so we know it's benign. And the malicious was set to a certain number or something and above. Like, that's when we call it malicious. This year, it's a little more fuzzy, and that was kind of to make it a harder data set to classify. Benign, we kind of trusted a virus total tag called trusted. And yeah, malicious, it was a little more fuzzy. Yeah, I don't want to say that any, like the specific cutoff we had, but it was just a little more fuzzy, yeah.
Can you comment on what the trusted tag means? I was wondering that when you mentioned it before. If you don't want to get into that, that's also fine.
No, I don't know. Like I would have to, I'd have to work at virus total, like to know that for sure. Yeah, I can tell you like.
This means you pay virus total money.
Cool. Follow-up AVClass question that even Hiram doesn't know.
What hope do I have?
The 2017 version of the dataset, did you add the family tag to that as well?
I think no is the answer, but I'm not sure.
Awesome.
Okay, we'll take one last question.
Have you thought about in the future releasing something maybe in a more unexplored territory like ELF binaries or ELF files where you might be able to distribute the binaries and all the other stuff, and no one's really good at it because no one's good at writing malware for Linux yet?
No, that's a good idea.
Maybe everybody is.
Yeah, it might be a smaller volume of data, so it might be less interesting, but it might have less controls and legal concerns.
Okay, thank you so much. Let's all give Phil a round of applause.